Hello, everyone. Welcome to today's webinar on how to make your research transparent. Glad that you can all join us. Thank you for being on from wherever you're joining from, especially for those of you who may be calling in from the particularly cold parts of the US and Canada as well. It's been a little bit more brutal than normal, so I hope everyone is staying warm. I'll officially just say before we get started that we have participants in listen-only mode because we sometimes have quite a few people joining in and it helps with audio clarity. But I'll encourage everyone to actively join in the chat. And if you haven't found it already, I'll point you towards it before I hand things off to Chris. You can probably find it yourselves, but I'll put a slide up later with details on how to access that. And in the meantime, for those of you who are intrepid and want to go ahead and find it yourselves, say hello in the chat, introduce yourselves, and we'll get started here as you're doing that. So to kick things off, I'll just briefly introduce myself. I'm Jennifer Shirk. I'm the Interim Executive Director for the Citizen Science Association, and happy to be hosting this webinar that will be led by Chris Santos-Lang, who is the co-chair of CSA's Ethics Working Group. We're also joined by CSA's Community Engagement Specialist, Rhianna Putnam, who's going to be helping with facilitating webinars in the future and will work with us to field the Q&A via the chat at the end. So you'll be hearing from her later on in this webinar as well. So briefly, before we get started, just a little bit about the Citizen Science Association. We are a member-driven organization with a purpose of serving and connecting leaders who are running, managing, organizing, designing, and researching citizen science to help advance the work in this field. So without saying too much about that, I'll just share with you the 4 pillars of our brand new strategic plan, which we will be releasing later on this year. The priorities that drive us are to elevate attention to integrity and excellence in citizen science, to create spaces that connect people across this really multidimensional and multidisciplinary field. And in doing so, we confront challenges that span those boundaries. And to facilitate that, we are striving to build CSA as a vibrant association with an open, transparent, and engaged culture. So this is the work that we're going to be doing over the next 3 years. But already I can say that some of the efforts to this end include our upcoming conference in March. Many of you may already know about this. For those who don't, you can find information at the following URL on our website. We'll be convening, we think, around 800 people in Raleigh, North Carolina, mid-March, across many different disciplines and contexts to discuss the practice of citizen science. And some of the things that will happen there are really core to the work of CSA, particularly in addition to the many sessions and keynotes and just great opportunities to meet and connect. We will be having spaces in that conference to connect with more deeply these cross-cutting issues that CSA advances through our working groups. And as you already know, this webinar is an example of one of the things that our working groups do, the working group on ethics. We also have working groups on education, research and evaluation, data and metadata. There's a new group being proposed on law and policy, and a number of others. But in brief, one of the opportunities at this conference is to connect with and deepen opportunities to engage with these working groups during that time. So if you're interested in that, I'm happy to share more, and Chris might say more about that as he takes us over later on. But Again, here today, webinars are another thing that we've started to do more of to help advance thinking in this field. Our webinars are archived on our YouTube channel, which you can click through to from our website. You can see here that the ethics group has done a series so far, most recently on situation assessment and stakeholder engagement. And even Chris had led one on basic 101 ethics and how they apply to citizen science. But others who can be led by some of our organizational leaders, such as one by citsci.org's Greg Newman, another working group on Citizen Science Day, and many more in this channel. So feel free to check those out and also look forward to a subsequent webinar from the ethics working group, which Chris will announce at the end of this session. So to not delay things any further, I'll just point out again that we welcome your engagement throughout this webinar via the chat feature. And if you haven't yet found the chat, look for a toolbar which may be at the bottom or the top of your screen. If you don't see this little chat icon, if you click on the 3 dots that say more, that will give you an option to open a chat. And I'll encourage you to make sure that you chat to all panelists and attendees, not just the panelists directly, because we encourage a conversation, folks sharing ideas and introducing themselves. So if you haven't taken the opportunity to do that yet, please do go ahead and do so now. And as we're going through, as questions occur to you, please feel free to add them into the chat. Rihanna is going to be keeping track of those, and then at the end of the webinar, feeding those questions back to Chris to respond to. So hang on as we go through and go ahead and share your questions as we go along. So at this point, I am going to turn this over officially to Chris to get us started on the topic at hand, how to make your research transparent. So let's hand off the screen to Chris. Whenever you're ready, take it away.
Thanks so much, Jennifer. Here we go. And does that look good? Jennifer, can you see that slide fine?
Yes, it looks great.
Super. Thanks so much. I wanted to also reach out, give some acknowledgement to the Center for Open Science and for the Metadata Group, who also helped to contribute some ideas. I take full responsibility for everything in this webinar. So if anything's bad, that's my fault. But if you see anything good, they get some credit too. I want to start off here by pointing out that the 7th of the European Citizen Science Association's 10 Principles of Citizen Science is citizen science project data and metadata are publicly available, and where possible, results are published in an open access format. Data sharing may occur during or after the project unless there are security or privacy concerns that prevent this. Also, the Do-It-Yourself Bio Code of Ethics says emphasize transparency and the sharing of ideas, knowledge, data, and results. And our one of our 4 pillars is now involving also transparency. So this webinar is a practical how-to guide to demonstrate some of the latest technologies developed to satisfy these ethical principles, not just legalistically, but also in spirit. It's going to demonstrate 2 free solutions as examples. One's the Open Science Framework, and the other is a homespun mixture of Google Drive, Google Sites, and Figshare. Both of these also leverage PubPeer, Creative Commons licenses, and research standards. First, however, because transparency technologies are still emerging, we're going to discuss qualities of transparency so you can evaluate additional technologies as they arise. We'll start by acknowledging concerns with transparency. Our current system to support innovators in the United States involves intellectual property rights which can be lost after the innovation becomes public knowledge. So some people worry that transparency may delay progress unless we first develop other means to motivate innovation. Our current system to judge people is calibrated for privacy about such matters as health concerns, personal finances, sexual behaviors, and personal preferences. Some people worry that transparency about such matters would ruin relationships unless we first recalibrate the ways we judge each other. Our current system to manage social conflict assumes restricted access to certain kinds of weapons. Some people worry that transparency about science that could be weaponized would unleash destruction unless we first develop new ways to manage social conflict. Our current system to manage access to electorates, consumers, and endangered species assumes limited ability to target them. So some people worry that transparency in science would enable mass exploitation unless we first develop new ways to manage access to such resources. Now, none of these concerns condemn transparency directly. Even privacy advocates demand transparency about how privacy is being protected. Like when Apple says, what happens on your iPhone stays on your iPhone, we ask, how can I be sure? Reliable privacy is typically achieved by redacting problematic information or anonymizing it. Current best practice obliges scientists to offer explicit justification for each redaction rather than justification for each disclosure. As examples of anonymization, random offsets can be added to the GPS coordinates for each observation of an endangered species, or human subjects' names might be replaced with randomly assigned ID codes. Technically, privacy laws cease to apply once data is anonymized, but hackers might re-identify data, so we should be interested in alternatives to anonymization as well. For example, another proposed privacy solution is called protected access repositories. The most transparent version of this would be something like an open source public chatbot that answers anonymous requests for aggregate statistics, such as how would results of this regression change if we included variable F or applied standard data cleaning process Y. Anonymization and protected access repositories might uphold the laws that block identification of specific individuals, but they will not protect individuals from being targeted for exploitation or discrimination on the basis of their visible traits, conditions, or affiliations like their gender or their religion. The first webinar in this series mentioned ethics tools that directly address our root concerns. So we've got regulatory agencies, interdependence, adaptive norms, and managed vicariance. The disadvantage of these tools relative to privacy is just that scientists can't implement them without help from the rest of society. Now, the upsides of transparency start with the fact that it makes science more effective. In 2008, David Hardesty and David Haga found that mental health professionals are 30% more likely to read a citation that includes a hyperlink, and an additional 75% more likely to read it if the paywall is removed. Each increase in transparency increases the rate at which errors in science are likely to be corrected and data is likely to be reused. But transparency also has a moral value highlighted in the first webinar of this series. Transparency and citizen science are the two tools of modern research ethics which address scientific negligence. Scientists are failing to protect the environment. We are failing to ensure healthy diets and behaviors. We're failing to safeguard water supplies and other infrastructure. If science were completely transparent, then any critic could tell what we aren't doing and could work as citizen scientists to fill whatever gap they prioritize. But if we fail to achieve transparency, then we're the only ones who understand what we aren't doing. So who else but scientists could be held responsible for social problems? Transparency also has special value in citizen science. A citizen science project's best defense against being labeled an intellectual sweatshop that exploits its own volunteers is to be transparent with volunteers and to seek their consent. Conversely, the best evidence that science is transparent is when independent citizen scientists are replicating it. If high school students all around the world are reproducing your results, then you've taken transparency to the next level. Replicated by arbitrary citizen scientists is the gold standard of transparency. Now, there are many ways to fall short of that gold standard, and it's healthy to be honest about the complications. To help you remember them all, I've invented this handy mnemonic, apricot. The first kind of failure is access. The movement to open access started with moving the content found in libraries to the World Wide Web. Why do we do that? Well, because between 1986 and 2004, the consumer price index increased by only 73%, but the expenditures for serials at research libraries increased by 273%. This serials crisis happened because the monopolistic power of the best journals corrupts free market economics. Open access publishing aims to correct this predictable market failure by shifting publishing costs to grant makers. But removing the paywalls from journals is just the beginning, because paywalls can shift to data, metadata, equipment, or other resources that are required to test replicability, to understand research, or to apply it. For example, consider the case of Isabel Myers and Catherine Briggs. In 1943, they developed a popular personality test called the MBTI, but they didn't put it in the public domain before they died. So their intellectual property rights transferred to CPP, a business which currently makes over $20 million each year charging people to use or administer the MBTI. Myers and Briggs cannot be supported by IP rights today because they're dead. Rather, their rights incentivize living innovators to continue the business legacy of the MBTI, but they de-incentivize innovators to continue its scientific legacy, since the use of the MBTI in any experiment would effectively give CPP a paywall against any test of its replicability. So for example, when citizen scientists need to measure personality, they're likely to choose an alternative instrument that they could use for free. In order to make science accessible, detangling knowledge from business interests, scientists now use open licenses for instruments, data, software, and hardware, as well as journals. And they support community labs and public facilities. By the way, this is a picture of the resource tab of our website where I've posted links to all the technologies described in this webinar. Just type citizen science ethics into a search engine so you can find all of these materials anytime you want. The second kind of transparency failure is permanence. That's when a study was made accessible for a while, but then accessibility ceases. For example, consider the case of the 80 studies published in the online Journal of Current Clinical Trials. When Taylor and Francis acquired the journal, they decided to discontinue it. Because it was an online journal, not printed, all 80 studies simultaneously vanished from every library of the entire world. Imagine having spent years of your life on research that suddenly vanishes. Scientists who try to achieve transparency merely by posting their work to their own website can likewise fail permanence if their web account is hacked or if they pass away. So to assure permanence of digital materials requires a trusted repository like Portico or something like blockchain. To assure permanent access to hardware and facilities required to conduct retests is an additional open challenge. The third kind of transparency failure is revisability. If a study becomes misleading because readers use obsolete drafts, then it's failed to be revisable. For example, consider the case of retractions. If you discover an error in an article that you published in a journal, that journal will probably allow you to retract it. A study by John Budd found that 80% of all retractions are instigated by one of their own authors. However, the same study also found that retractions aren't necessarily effective. Retracted articles were cited an average of 8 times each since being retracted, and 94% of those citations treated the original publication as completely valid, never mentioning that it was retracted by its own authors. The new strategy to provide revisability is called post-publication peer review. It typically involves an open online discussion board like PubPeer for each published work. Someday, there may be artificial intelligence or search engines that compiles post-publication peer review hosted across multiple platforms, but our more immediate challenge right now is just to educate all readers to habitually check for post-publication peer review whenever they read any article. The fourth kind of transparency failure is intelligibility. Even if a study is free to download, it may be too difficult to translate it into useful language or useful form. As an example, consider IBM Watson's supercomputer. Remember when it won the game show Jeopardy? Well, now doctors around the world have an Ask Watson button that they can press to find out what medical treatment Watson would recommend for their patient. By 2020, IBM predicts that medical data will double every 73 days, and that such growth will eventually force all human doctors to rely on these kinds of buttons. So what Watson already reads is like 13 languages and follows over 300 medical journals. What human can do that, right? But Watson doesn't read everything. And if you don't publish your medical discoveries in one of the journals that Watson follows, your research would be useless to all Watson patients. Now, in the long run, making your research intelligible may amount to reporting standard meta-analysis statistics and using publication channels that are reviewed by artificial intelligence, channels like Google Scholar, Base, Core, and the Watson corpus. On the flip side of this relationship, it's important that artificial intelligences process post-publication peer review. The US government also maintains a corpus, and it's so serious about forcing scientists to make their work intelligible to them that the FDA Amendments Act actually requires all scientists to pre-register certain clinical trials at clinicaltrials.gov within 21 days after the first human subject is enrolled. This includes studies that are even outside the United States. So use the link from our website to see if this law applies to your research. And don't be surprised if governments launch similar resources to track non-clinical trials as well. The fifth kind of transparency failure is citability. It's especially apparent in the age of fake news. Imagine people could easily find your work on the World Wide Web, but would also encounter variants that lead to contrary policy choices. If people confuse the variants, then your research has failed to be citable. As an example, consider videos and water cooler conversations that spread such insights as science finds that coffee is good for you and science finds that coffee is bad for you. You might wonder, how much coffee? Better than what alternatives? Or good for whom and when? If specific evidence is not cited, then it can be impossible to know whether scientists are disagreeing with each other or simply measuring different things. Persistent URLs, such as DOIs, can make science citable in written communications, but making science citable in oral conversation remains an open challenge. The sixth kind of transparency failure is objectivity. Any author must choose what to include in any publication. If readers seek information that was excluded, then the publication has failed to be objective. For example, consider metadata. Scientists increase objectivity by publishing their data in addition to the results. But a table of numbers would be useless without metadata to explain what each column means. In a controlled experiment, at least one column in the data is going to distinguish the rows associated with an intervention. So the metadata will need to explain what the intervention happened to be. It might require a video recording the intervention, or it might require results from tests confirming the composition of a drug or placebo, or it might require STL files that can be used to replicate equipment with a 3D printer. But even a complete video diary of a scientist's experiences would be subjective because scientists choose what to experience. One scientist might never test the purity of her materials. Another might never know the exact design of her equipment. Another might not use containers like Docker, Singularity, or RKT to document the computational environment of her analyses. Furthermore, some readers have motives that are beyond mere replication of experiments. For example, some may be studying the sociology of science, assessing supposed best practices, or trying to measure the contributions of specific individuals in a team. The seventh kind of transparency failure is timeliness. Even if research will eventually become transparent when published in a journal, that might be too late. Humans are learners, so in the process of gathering and analyzing data, we inevitably learn something about how to measure our subject, how much data is needed, how to clean the data, and what covariance to take into account. And sometimes these learnings mislead and make our data seem more valuable than it actually is. So we should always test our learnings on fresh data. But budget constraints tempt us to rely on whatever data we've already got. The best way to prove that we didn't succumb to such temptation is to be transparent about our data collection and analysis plans before we implement them. That's the typical explanation of timeliness failure. But citizen science projects have an even larger concern. Suppose a volunteer does not fully understand an experiment she's supporting until after it's already been conducted. Suppose she realizes only after the fact that she has a better idea, or that she considers the research she supported to be unethical. Ethical citizen science demands engaging volunteers all the way along to make sure they understand the evolution of our thinking. In summary, the gold standard of transparency, replicated by arbitrary citizen scientists, means treating your research like a public treasure. It means making sure your discoveries will never be lost and that others can continue your legacy even if you or your group were to disappear. Transparency secures your position as a giant in the phrase Isaac Newton made famous: "If I have seen farther, it is by standing on the shoulders of giants." Transparency makes sure your research can be continued by people who never met you, people beyond your company, school, or nation, people beyond your profession or field, and even by artificial intelligence. Processes to achieve transparency are sufficiently complex that it's most effective to formulate them as sets of habits and technologies. So the rest of this webinar will demonstrate two technology mixtures and show how they stack up in terms of apricot. Both mixtures are designed to support the same set of habits. The first habit is to use an open notebook, which is essentially secure public cloud storage, but ideally maintains revision history as well. In our first example, we're going to use Google Drive because it offers 15 gigabytes of free storage. But you can also get at least 5 gigabytes from the Open Science Framework, GitHub, Box.com, Dropbox, iCloud Drive, OneDrive, or Amazon S3. And you can also mix these technologies. If you like LaTeX, Overleaf is a great place for the manuscript part of your project. To start our first example, I created a new Google account for it. Then I created a folder and set sharing to give everybody the ability to view files. You can also create a separate folder for private files, but I'd anonymize data even before sharing it privately, so I've never encountered a need for a private shared folder. I also paid $2 for the folder notifications for Google Drive app. That option might not work, might not be worth the cost for everybody, but I did confirm it does work. The first file to add to the public folder is the agreement you have to sign to be authorized to edit the files. And this is mine. Notice that it has a copyright notice on the bottom. Every document you create will need its own copyright notice. You can copy it from other documents or from the Creative Commons website. Many people recommend CC BY for papers, the CC 0 for data, and the MIT, GNU, or Apache licenses for code. But my consent form allows any contributor to place any work under any license, so I think it's most clear to use the most permissive license up front. That's why I use CC 0. A truly open notebook would allow anyone to be able to get notifications of changes, so I created a Google group and set my account to forward all emails to that group. The second habit is to maintain an intelligible front page. It will explain all the files and how they fit together. You can get free web pages via Medium, WordPress, Tumblr, Blogger, Facebook, but I use Google Docs in this example because it has revision history. You can embed any Google Doc in your website or blog using the Publish to the Web action. However, in this example, I created a new Google site in my Google Drive and embedded the Google Doc there. Fair warning, the Google search engine did not index my site until I registered for Google Analytics and used Google Console, so be prepared for that complication. The front page should tell users how to cite the project, how to get notification of changes, how to become a contributor, and how to participate in post-publication peer review. It's important to specify a particular platform for your post-publication peer review, otherwise comments might get left in places you're not expecting. I recommend the PubPeer platform because it permits anonymous feedback and notifies authors by email. However, your project will not automatically appear in PubPeer until you actually archive it to get a DOI. Google Docs allow you to see revision history just like in Wikipedia, so don't worry about collaborators messing anything up. You can always restore previous versions. Whenever you add a file to your open notebook, add a link to it here on this page. Add manuscripts, surveys, forms, data maps, annotated bibliography, marketing materials, schedules, budgets, videos, scanned documents, everything. The third habit is to use stable file formats. You want formats that can be used for free, so prefer R, Octave, Torch, and Python over SPSS, SAS, and Mathematica, for example. You also want formats that retain all information. GIF, JPEG, and MP3 are examples of formats that lose information because of their compression. They're great formats for publishing, but not for archiving. You want formats that do not create security issues. RTF and DOC are examples to avoid. DOCX is secure. Finally, you want formats that remain editable. Now, one would usually avoid the PDF format because it's not editable. But for manuscripts, you actually should maintain two copies, one editable and the other a PDF, because Google Scholar and Core privilege PDFs, and that makes PDFs uniquely intelligible. The editable version of your manuscript could be a Google Doc or LaTeX file. Your data could be in Google Sheets or XML or CSV. The preferred formats for images are PNG and SVG, but JPEG and PDF images don't need to be converted. FLAC is preferred for audio, and OGG, OGV, and MKV are preferred for video. All of these formats have free readers and editors and are expected to remain widely supported for the long-term future. The fourth habit is to check the objectivity of your research plan before collecting data. Here's a link to a handy chart showing us how to find checklists of what to document. Such checklists are for broad categories of research, so it might be even better to model your research after an exemplary study if available. You can also submit your plan for peer review as a registered report. The fifth habit is to permanently archive your work at citable stages. Some of the major repositories today include Figshare, Zenodo, Harvard Dataverse, Dryad, Archive, Databrary, ICPSR, and the Open Science Framework. For this example, I choose Figshare because it gives 20 gigabytes for free. It's archived in Portigo. It's indexed by Google Scholar, Base, and Core, and it generates a DOI, which is indexed by PubPeer. It's pretty powerful. Now, Permanence doesn't require free storage, but you've got to make sure that the costs aren't ongoing because eventually you'll potentially miss a payment. Each time you archive your work is called a registration. It's a citable snapshot in time. If the registration is just a research plan ready for review, we call it a pre-registration. You can also register your data when it's ready for analysis, or when a manuscript is ready for review, or after publication. Also, register anytime your Google Drive contains enough unarchived work. If you've got months of work waiting to be archived, don't keep waiting for a milestone, just back it up right now. Each registration should include everything in the public folder. Manuscripts, data, materials, everything. Download your Google Docs as ODT, ODS, and ODP formats, and don't forget to download that front page you put together. Once you've made an archive, generate a DOI. The sixth habit is to check intelligibility through peer review. Ideally, this would involve convincing independent researchers to transparently test the replicability of your findings. The next best thing may be to submit to a peer-reviewed journal, and to be transparent about the feedback you received. Take care not to submit to a journal with a paywall. Recall that fewer people read articles that have paywalls. I recommend publishing in journals that are indexed by core. Our second example uses the Open Science Framework as the file system, front page, and archive all in one. Rather than make a new account for each project, you'll only need one account on the Open Science Framework. Log into your account and create a project and make it public. You specify a copyright in the header, but it's probably a good idea to include copyright in specific files as well. The wiki part of your project is its front page. It has revision history, just like Google Docs does. You can edit other kinds of files on your computer and upload them into the Files section of your project. Use stable file formats like ODT. You get a revision history if you upload files that have the same name. Instead of public and private folders, the Open Science Framework has components, which can be public or private. Each component has its own wiki and its own file system. To grant someone editing permissions, add him or her as a contributor to the project or component. Each contributor will receive an email directing him or her to set up an Open Science Framework account and password. Any contributor with an account can sign up for their own notifications. To provide notifications to non-contributors, you'd need an email list, like in the previous example with Google Groups. The Open Science Framework has add-ons that you could use to archive files to Figshare, Google Drive, Amazon, Bitbucket, Box, Dataverse, Dropbox, GitHub, GitLab, OneDrive, or OwnCloud. But these archives would all exclude the wiki pages, and the Open Science Framework might be permanent enough on its own anyway. It has a $250,000 preservation fund to ensure that it will remain accessible for at least 50 years. But even if you count the Open Science Framework as your permanent archive, you still need to create frozen snapshots in time for citation purposes. There's a simple process to create each registration and give it a DOI. And then use the same habits of objectivity check and peer review that you used with the other set of technology. So here's how those two examples stack up in terms of apricot. Both technologies offer free access to all users of the World Wide Web with accessible file formats and open copyright licenses. Opening access to equipment, supplies, and facilities remains a challenge, but that's probably not something that we should expect from these technologies. Whether one of these technologies is less permanent remains to be seen. Both may be adequate. The Center for Research Libraries audited and certified Portico, which includes Figshare, and it'd be nice to see the Open Science Framework pass a similar independent audit. Now, on the other hand, the whole paradigm for permanency could shift with blockchain. For revisability, the Open Science Framework and Figshare both can be updated at any time by their authors and can collect updates from non-authors via PubPeer. Convincing readers to check PubPeer is the only open challenge. The relative weakness of the Open Science Framework might be its intelligibility. Figshare is indexed by Google Scholar, Core, and Base, but the Open Science Framework is indexed only by Base. Furthermore, the branding and style imposed on every Open Science Framework project has been known to confuse some people into thinking that all contributors are employees of the Open Science Framework. Standards of intelligibility may shift, however, if artificial intelligence becomes the mediator between humans and languages. The two technology mixes seem equally citable. Both generate a DOI. Being citable around the water cooler and a news TV remains the open challenge. Both technologies facilitate objectivity by maintaining version history and allowing users to archive all types of files, but Google's version history is hidden from anyone who doesn't have edit permissions, and the version history gets lost upon archiving. For both technologies, refining and establishing checklists of what to document remains a challenge. Finally, Both technologies facilitate timeliness via notifications and immediate public access. Setting up notifications in Google was a little tricky. Engaging volunteers enough to actually follow the evolution of a project may remain a challenge, but I think Wikipedia has demonstrated the potential to overcome that challenge. In summary, many technologies are available to increase the transparency of your research. If the options seem too complicated, the Open Science Framework offers a straightforward solution under one umbrella, and they've got a great community to provide wonderful support. If the Open Science Framework isn't flexible enough for you, you can use powerful tools from Google. There are many other possible technology mixes, and more may emerge. And you can use Apricot, that mnemonic, to evaluate them. So thank you for your interest in this webinar. Our series is going to take a break in March for the SITSI 2019 conference in Raleigh, North Carolina. Hope to see you there, but also hope to see you in May for our webinar about ethics review. And now I'm going to look for your insights in the chat, see what you might have, other suggestions you may have that people should know about, or questions you may want to ask.
Thanks so much, Chris. This is this is Jennifer. Oh, excuse me. And before I turn it over to Rihanna, who I know is tracking some questions coming through in chat, and to give people some time to put some questions into chat, I just want to say thank you again for pulling all of this together along with folks from your working group. It's great to have working groups helping to reveal some provocative ideas that we can think together about as a field, and interested in more about the Apricot acronym, and good to see that circulating for feedback from the broader community. And in fact, some of the questions that are coming up here are from that. So Chris, thank you again for pulling this together and for revealing your ability to say that this is work of yours and your working groups that you're taking responsibility for and sharing with the community to invite their thoughts and feedbacks. Rihanna, let me turn it over to you to help voice some of these questions that are coming through. And folks, don't forget to use the chat, please, to share your thoughts.
Great, thanks, Jennifer. Looks like first off, we have a question from Duncan Bailey. He's wondering how to implement the Apricot acronym from a standalone platform standpoint.
Oh, thanks. Appreciate that, Duncan. And I'm thinking you can just look at that platform in terms of these different technologies like we did in the end there for those two mixes, and think about the kinds of failures that could arise, of these different kinds of failures. Think about whether they could arise with whatever standalone platform you're looking at. That said, you don't have to use only one technology. It just looks like it's really convenient to build something like the Open Science Framework that is under one umbrella, but you do have the option, even with the Open Science Framework, to use lots of other technologies. They're happy to mix with other things like Figshare. So you don't have to expect one technology to address every potential way of failing. I think you need something like PubPeer is going to be a separate kind of a thing, or you know, the Creative Commons licenses. It seems to be a community problem to figure out how do we deal with transparency. So I wouldn't expect a single platform to be able to protect against every possible failure.
Great, thanks, Chris. If anyone else has other questions, feel free to type them in the chat. Looks like Helen's writing in, wondering that in government, there are often constraints on the tools and platforms we can conduct our work with because of security issues. Google Docs is often frowned upon. Are you aware of similar barriers with Open Science Framework? Are there any platforms you can suggest for folks working on secure networks?
Yeah, so I am not aware of similar issues with the Open Science Framework. Probably the government has, or different organizations who want to make sure that things are appropriately transparent or appropriately private when they need to be, would make a list of which kinds of technologies are considered acceptable. So I'd be looking to those organizations, whoever your employer is, or any stakeholders that you're planning to work with, to find out whether they have a particular list of things they need you to work on. The United States government, as I mentioned, clinicaltrials.gov is the thing that they use, where they want you to, as a repository, to put in, here's your stuff. It's not very complete, the clinicaltrials.gov. So I don't think it's the best thing out there, but it is controlled by the government, and so they can feel comfortable with it. And so you need to be sensitive to the fact that you may have stakeholders who have particular platforms that they have special comfort with. I also noticed that there has been some suggestions in the chat about other resources that we'd want to put into our website. And thank you for sharing those suggestions. And if anybody thinks of other suggestions that they don't put in this chat, you'll find our contact information on the website, and please let us know, and we'll try to keep on maintaining and building up that list of resources for you, and hopefully it'll grow and it'll get even better when you come back to it in a year from now.
Great. Do we have any last questions for Chris?
So with some remaining time, in case folks do want to take the time, and there's a question coming in just now, I did just want to briefly mention, since Chris was saying about this working group list of resources growing, again, there's opportunity to get engaged with this working group. One of those opportunities to connect will be at the conference in March, but certainly through the portal on the website, please do reach out if you would like to be part of exploring these resources, exploring dimensions of these resources, and the context of how they can be used. That group, I think, is very open to engaging those ideas moving forward, especially with some new resources coming into that group via work that Karen Cooper, who's on this webinar, will be leading over the next few years. So look for more from the ethics working group and ethics in citizen science. Rhianna, sorry, I started talking right as that question came in. I'll let you go ahead and voice that.
Yeah, so Daniela has a question. She's curious about whether just processed works that are fully available need to be fully available and editable, or if also the collected data through just citizen science, even before it's processed and published, needs to be made public and available.
Yeah, that's a really great point. I want to emphasize that that if you only make your process works available, clearly you're going to have a problem with timeliness, right? Because you've delayed before you make things available. In citizen science, that's especially a problem because the volunteers themselves might not know what they're really getting themselves into if you don't make yourself transparent until after the research is already done. Also, we have all those other issues with transparency that have been raised regarding publishing analysis and data plans ahead of time. So if you only you've only published your processed works, you've got a major transparency problem. But also, if you were to exclude all of the pieces, even if afterwards you didn't publish your data and your budgets and who did what and things like that, that would be an objectivity issue, because there's a whole bunch of people who may want to know things about your research that you wouldn't have thought to put in your processed work. So if you don't really share everything, and it's hard to think about all the different things that you would need to include. And that's why I recommend trying to advance these checklists of things to publish. If you don't publish all this other stuff, you'll have other people who would want to contact you and get more stuff. They'd be like, well, what about this? And they have questions, and maybe they can contact you, so include your contact information. But imagine you move on to some other things in your life, you know, and you just don't have time to come back and think about that research you did 10 years ago. It'd be nice if you were able to get all the information out, in all of that in the package, and so that you don't have to try to dig back through 10 years of stuff to answer questions that come up later.
Great. Did that fully address your question? Great. And we have some follow-ups in the chat coming in about that. Stacy Lynn wanted to add that sometimes data may need to be processed to some degree because of data sensitivity issues, like Chris mentioned early in the webinar, in order to protect conformance, different endangered species and such. Karen also wanted to add about data sharing responsibility or repositories is that if you don't license it, e.g. put a Creative Commons license like the CC-BY, that it remains proprietary.
Yeah, and I see Danielle is also pointing out that people might scoop you. If they find your data, they might find it and they might publish, they process it and take away your intellectual property. So these are all issues that we've discussed earlier about privacy and wanting to deal with issues of intellectual property, and what if people use the data in ways that hurt others in judgments and things like that. And all four of those concerns are all concerns that you need to sort of deal with. Sometimes people will say you embargo your publishing, so you get all your stuff, and you can do this in the Open Science Framework. You can take sections that you say, and you can even register stuff out, and so that they know that you registered it ahead of time, but it's embargoed, which means there's a time delay to make sure that no one can scoop you and you protect intellectual property. And the other options, of course, are to just, if we deal with these issues of judgment and intellectual property and things like, so we don't have to be private and we can be more transparent as a society, that would obviously be the ideal situation. And I'm hoping 50 years from now that people don't really worry about privacy.
Great, thank you, Chris. Do we have any other questions coming in?
Well, short of hearing other questions, let me just say thank you again to Chris for sharing this information, to the working group, as well as the data and metadata working group, which I understand had some input into this, and others who've been part of generating this webinar series. Thanks to Rihanna for helping with the Q&A, and to all of you for joining in and sharing your thoughts. Again, there's more opportunities to engage these ideas, to deepen them, and to advance them in new directions. Please do get in touch with Chris. There are contact points through the ethics working group website on citizenscience.org. And I hope that some of you take the opportunity to use that, as well as the chance to engage at the upcoming conference in March. So thanks again for joining in, and we'll look forward to being in touch in future fora.